Hey students, this is lesson 8.7. We're going to learn some how to factor some special cases here. Specifically, we're going to learn how to factor perfect square trinomials and the difference of two squares. Go ahead and do the review here. I'll check back with you. All right, here's some things you have to know about when you're looking for these special cases. That perfect square trinomials, they look like this. They're going to be in this form, where you have a square number here, a square number here, and then the middle number is twice the square root of the first number times the square root of the second number times 2. And go ahead and look at the other cases here that you should recognize. If you recognize these, it's pretty easy to factor. Go ahead and do 7, 8, and I'll check back with you. Now, this can be factored the way we've always been factoring, but if you recognize this, that this number is a perfect square, and this number is a perfect square, and that this middle number is, if you think of the square root of this number as 2, and the square root of this number is x, and you multiply those two together, and then double it, and you end up with this, then it's going to be a form of perfect square trinomial. And it matches this form, a squared minus 2ab plus b squared, and that will factor into a minus b squared. So our a here is x, and our b here is the square root of 4, which is 2. And it's minus because of this subtraction here. So x minus 2 squared. And to check that, you could just expand it. And you get first two terms are x squared, the outside, the inside, and the last. And that equals negative 4x, so we're good there. Now you could factor this the normal way, where you look for two numbers that have a product of positive 4 and a sum of negative 4, and that of course is going to be a minus 2 and a minus 2. And then you could just write it this way as your final answer. All right, you try that. All right, suppose the area of a square can be represented by the expression 9x squared plus 24x plus 16. What is the expression for the length of one side of the square? So the area of a square is the side times itself. So, and our area is this expression. So I'm going to substitute that for the area. And I know that equals some number times itself. And since it's a trinomial, you probably know that it's a binomial multiplied by itself. So you have to think of what number times itself is 9x squared. And since that can be written like this, and what number times itself is 16, that can be written like this, it's a perfect square. And this middle number, if I take this 3 and this 4x and multiply it by 2, I get 24x. It fits the form of a perfect square trinomial. So I know that my answer is going to be 3x plus 4. So each side of the square is 3x, because 3x plus 4, because 3x plus 4 times itself is equal to the area. Go ahead, you try that. All right. Remember, the other special case we have is the difference of two squares. If you have the exact same numbers, but the b is opposite, when you multiply those together, that gets rid of that middle term. And so you end up with a squared minus b squared. So, so if you recognize that this number is a perfect square, which it is, and this number is a perfect square, and there's subtraction, that that is the same as So we have this form, a squared minus b squared. That will be the same as a minus b times 1 a plus b. So I can factor this into my a is x, and 1 is minus and 1 is plus, and my b is 8. All right, you try that. All right, here's another problem like that. We're going to factor the difference of two squares. Again, you have to notice that this number is a perfect square, so you have to be able to write it like as a square. And 3x multiplied by 3x is equal to 9x squared, and 25 is 5 times 5. So that means we're going to be able to write it as 1 minus and 1 plus, and whatever number is squared for the first term, which is 3x, goes there, and whatever number is squared for the second term goes there. All right, you could try that. Okay, sometimes, well, the first step you always want to do when you're factoring a polynomial is to check and see if there's a perfect square factor built into that. So, not a perfect square factor, but just a common factor. So look for the greatest common factor. And it looks like the greatest common factor here is 3. So start by factoring out that greatest common factor, and then rewrite it. So we have 4x squared minus 1. And now check that binomial and see if you think you can factor that. Since this is of this form, where the first term is a perfect square factor of 2x, and the second term is a perfect square factor, this is the difference of two squares. So we can factor it that way. And so we're just going to write 1 minus and 1 plus now, and then the square root of each of those factors, which is 2x and 1. And now that's completely factored. All right, go ahead and try that. All right, go ahead and do the lesson check, and we'll talk about this next time we meet in class.